Today we are going to start reviewing the single phase circuit, and it might take 2 lectures. And it's very important. Once we review the single phase circuit, it'll be easy to do the 3-phase, and it'll be easy to continue in our syllabus for the electric machine. I know you had in circuit 2, but I want to make sure that you can solve at least the fundamental problems that we needed in the electric machine course. I uploaded the folio with the summary sheet that I'm showing you now. Just I'd like to review the single phase. If you have a voltage showing in this figure, you have V1 is equal Vm sine omega t. So Vm will represent the peak value, the maximum value of the voltage. Omega will represent the angular frequency. And there is a relationship between the angular frequency and the frequency in hertz. So this is the equation. V equal Vm cosine omega t plus phi. That's in general. Because if you don't put phi, it means zero shift, it means start from zero. This is a sine wave start from zero. The relationship between omega and f, as you know, is equal to pi f. So if 60 hertz, multiply 2 times pi times 60 hertz, you will get around 377 radian per second. Usually in AC sinusoidal voltage or current, we use the phasor concept. And the phasor concept will be the voltage, like in bold like that, equal Vm, and then just you put the angle phi. What about if it starts from zero? You put Vm on angle 0. And you want to make sure that the angle, radian or degrees. Okay? We don't use the maximum value on the current. Put this in your mind. We use the root mean square. So if you have any appliance in the house, any appliance, food processor, blender, iron, anything, the voltage written there, it's the root mean square. So when we say 120 voltage, it does not mean the maximum. It does not mean varies between 120 to negative 120. No, that's the root mean square. Do you know what's the difference between root mean square and the peak value? By equation, you say the VRMS is equal V maximum divided by root 2. You know that, right? But what does it mean? The physical meaning. We have the average value, we have the root mean square. What does it mean, root mean square? The physical meaning. Anybody? Yes. Which is equal 0. Why? Because when you look at the sine wave, you'll find that the positive equal the negative, and the average means the area under the curve. So the positive area equal negative area. When you add them, you get 0 over one cycle. So the average value is equal 0. What does it mean average value equal 0? It means the sine wave or the source that have sine wave does not have any DC component. If you have average value, it means that the input voltage has DC component. If you add DC component to the sinusoidal, then you get average. What do I mean by that? Like that. So if you have something like that, that's pure sine. The average equals 0. Means there is no DC component. But if the voltage look like that, still sine wave, but it's above the x-axis, above the time axis. What does it mean? If you find the average, that's the positive, that's the negative, it will give you average value. It means there is DC component superimposed with this signal. So the average value in pure sine wave is equal to 0. What's root mean square? Root mean square, the physical meaning of it, you want to find the energy, the equivalent energy that can be done with the equivalent DC. So what they did, they got the AC voltage and they got a DC source like a battery. And then they got the AC, they put like a resistor. And this resistance, they start to see the heat coming out of it. So that's energy supplied by the AC supply. When they got the DC power supply, it changed the voltage of the battery till they get the same energy, the same heat by the same heater that they put in the AC. And then they found the equivalent battery that will give the same energy by the AC component. So it's like the equivalent energy produced by a DC source. That's the meaning of root mean square. That's why we call it the effective value also. It has two names, root mean square, RMS, and effective value. What's the difference between both? Effective value, that's the physical meaning. Means this is the value, give the effect as the DC. Root mean square is mathematical. How you get it, how you get the effective value, how you calculate it. Root mean square, you square it, find the average, and then you find the root. Okay, so we always use root mean square, and that's the phasor. So we will not use the max, but we're going to use the root mean square. All right, let's just look for one example here. Express the following voltages in a phasor form using the root mean square voltage values. So that's the first one. V1 is equal 141.42 cosine 300t. So what do I understand from that? Understand that the maximum value of this voltage is equal to 141.42. So I'll say that in voltage A, the V max is equal to 141.42 voltage, and the omega, because that's omega t. So you understand omega is equal to 300 and radian per second. And phi is equal to 0. There's no shift, means start from 0. Also, there's something important we should know. How the people agree about the phasor. They agree that it should be expressed as a cosine, positive cosine wave. So that's cosine wave. So you can express this as a phasor. And I'm not going to tell you what about sine. I would say that later, but should be cosine. So I will say now that the phasor of the voltage V1, and because I don't have volt here, just I can put this on the top of it, it's equal to the root mean square. What's the root mean square? The maximum value divided by root 2. And here I'm going to put the phase difference, the angle of it. What is the angle in this case? 0. There's no shift. Okay. And how you sketch it as a phasor? It will be like a vector. Angle 0, it will be like that. Start from 0. The length should be proportional to that one. So if you calculate the value, you'll say 141.42 divided by root 2. So that will give almost 100. So we'll say it's equal 100, angle 0, and the unit is voltage. So this length of this vector or this phasor should be proportional to 100 and an angle 0. All right. Yes.
What value you get exactly?
Root mean square. By the root 2, you get the root mean square. And that's the way you're going to sketch it as a phasor, just line on x-axis. Let's go for part B. The voltage V2 is the same magnitude, but shifted by pi over 6. So it's easy. You will say V2 is equal to the root mean square. We already did it, the same value, 100. But in this time, the angle will be equal pi over 6. You have options, two options. Either you express it in radian or degree. If you are familiar with degree, I'll say pi over 6 is equal to 180 over 6 would be equal to 30 degree. So you can say 30 degree. That's the voltage V2. What about 3? It would be the same thing. It's just the shift is different. It's negative. So it'd be negative 30 degree. How we sketch the 3 voltage? Let's just That's VA. And all of them, they have the same magnitude. I'll write that's V1 phasor. The second one, 100 and angle 30, positive. The question is, when it's the positive angle, positive phase shift, it should be on the top of V1 or below V1? Above V1, below V1. Or in other words, leading V1 or lagging V1? It's positive. The angle is positive. So let's choose another color here. That will be V2, the same length. So if it's the same length, you can make like, if you make a circle, that will be the radius. And that will be same length, 30 degree, and that's V2. Now V3, it's negative, so obviously will be below. And the angle is equal to -3. So V1 an angle 0, V2 an angle positive 30, and V3 an angle -30. How express the relationship, the phase angle relationship between V1 and V2? You say V2 leads V1 because it's before V1. So you can write here. V1. What about V3? V3 lags V1, but it's not enough. You have to define the quantity of the angle. So V2 leads V1 by 30 degree, and V3 lags V1 by 30 degree. Don't say lag it by negative, because already lag means negative, right? So that's the meaning of lag and lead in general. I want to make sure that you understand this concept. What else? Here, what's the difference? Phase difference. Okay, what is the phase difference between V2 and V1? Difference between V2 and V1 at 30 degree, you just subtract both angles. It's easy here because V2 an angle 30, V1 an angle 0. When you subtract 30, minus 0 is equal 30 degree. What about if both you have different angles? What do I mean by this? Let's say assume I'll express in the phasor. When I say VA is equal 100 on angle 15 and VB 100 angle 35 degree voltage. So if the question is find the phase difference between VA and VB, what are you going to do? You will say that the angle of the voltage A is equal 15 and the angle of phase B is equal 35. So the difference, if you sketch it, you can say that this is 15 and the other one, VB, is 35. So the difference will be theta is equal theta BA is theta B minus theta A. Theta B is equal 35 minus 15 will be equal to 20 degree. So you can say that the phase difference between VA and VB is equal 20. And to be precise, more precise, what should you say? You will say VB leads V by 20 degrees. That will make sense because you know 20 degrees above or below. So that's the way how you express lag and lead. It's very important. All right. What else in the question here? What is the difference? Okay, you can do that. V3 and V1 the same would be 30 degree. Let's take one more question here. Okay. That's question 2. A coil having resistance 72 ohm and an inductance 31.8 millihenry is connected to 230 volt. Any coil has inductance and resistance. We don't have practical in real life. We don't have pure inductive coil because coil made of wire. Since it's made of wire, any wire has resistance. So how can you represent the coil? That's the coil. And the equivalent circuit for the coil, resistance plus inductance. And the resistance here is equal 72 ohm, and we call it R, and L, the inductance is equal 31.8 millihenry. And it's connected to AC voltage. They didn't say anything. And 50 hertz. That's usually when we have an appliance in the house, we give me the voltage and the frequency. So what is 230 volt? Is the maximum or the root mean square? The root mean square. Nobody given big value. Because I mean, when you go here and you look at the blocks and the outlet, the voltage coming out, if you measure it by the voltmeter, it's root mean square. So I understand that the source has voltage equal to 30 volt, and I'll remind myself it's root mean square, and the frequency is equal 50 hertz. From frequency, usually we need to find the angular frequency omega. So I'll say omega 2 pi f and 2 times pi times 50 hertz, so we'll get around 314 radian per second. 314 radian per second. So I'm ready now to continue. Calculate the impedance of the coil. Impedance. As you know that your impedance equals Z. How can you find the impedance? What does it mean, impedance? Impedance, it's similar to resistance, but the difference between impedance and resistance, impedance is more general than resistance because resistance is a scalar value, doesn't have direction. But impedance can have a real part, and imaginary part, can be like a vector. So it has magnitude and an angle, but the resistance has only magnitude. So Z equal R plus J XL, or you can write Z equal R plus J omega L. What does it mean, J omega L? Every element in electric circuit has impedance. Let me show you what the value of, I will remind you. I'm sure that you did it in circuit 2, but just let's refresh your memory here. That's the impedance. If it's resistant, doesn't have reactance, but has impedance equal R, the same thing. If it's in inductance, the reactance will be omega L, and the impedance will be equal J omega L. If you have capacitor, so the impedance is 1 over J omega C. So you have to remember that how we calculate the impedance of the inductance, J omega L. And the capacitance, its impedance equal to 1 over J omega C. Obviously, the impedance of the inductance and the capacitance depend on frequency, affected by frequency. So if you change the frequency, the value of the impedance, of the inductance, and the capacitance change. But ideally, the frequency does not affect the value of the resistance. As you see here, the resistance is not a function of the frequency. So saying that, now I have J omega L, that's the impedance of the inductance, and I have the resistance equal 72 ohm. I'd like to calculate the impedance of the inductance here separately. So I'll say ZL equal J omega L. J and omega, I got it 314. And L is equal 31.8 millihenry, so divided by 1,000. So the answer should be in ohm. Have 314 times 31.8 divided by 1,000, get 9.98. Let me just round it to make it easy. 10. It's 10. The unit of impedance is ohm. So 72 plus J10. We express the impedance in complex form. We should be able to express the impedance in phasor form, magnitude and an angle. I advise everybody to get a calculator that has the complex function, because it will take you a long time to convert from polar to Cartesian, Cartesian to polar, find the magnitude, the angle, and you don't have time in the exam. You have only like 3 minutes every question. So get anyone. This one I have like 15 years, okay, fine. You don't have to get programmable, anything like that. Just get something has the complex function. And there are many. This is like Casio, X, it's just old one, but it's fine, easy. So I'll convert it. I wish that you have the same thing. I will tell you how you do it. But all what's supposed to do, any calculator, you change the mode to complex. So I have it here, number 2, I have complex. And then I will say 72 plus 10i. And I will convert it to polar form. And it just do it in second. So I have 72.7. And the angle is 8 ohm. That's always easy. It's always easy to do this step. Just get the impedance as a phasor. And I'll tell you now why I mean that. Now, that's A. We did part A. We found the impedance, total impedance of the coil. The second part, the circuit current. You want to calculate the current. So the current I, everything will be root mean squared. I found the current I, very simple. R and L, they are in series. So I got the Z, the total. So it's like, if you sketch it, you have Z like that. And you got the voltage source Vs. And that's the current. So it's easy, Ohm's law. I equal Vs over Z. And Vs, I have it equal to 30, and the angle is 0. No shift. Might say, they didn't say anything about the shift. Once they didn't say anything, I assume Z equals 0. And Z, I got Z here, 72.7 and angle 8. So the result just, I'm using all the complex form here. So 72.7. So I got 3.16 and the angle -8 M. Because how you do the phasor, when you are dividing, you subtract the angle, be 0 minus 18, you get -18. That's the current, and that's good. T, the phase angle. So this question actually is not complete. Phase angle of what? The current of the impedance. So maybe we want to find the phase angle of everything, and that's good. The phase angle of the voltage is 0. So I can write for you here that theta voltage is equal 0. And the theta current is equal to -8. And theta Z of the impedance is equal 8. So obviously, there is a relationship between the angle of the impedance and the angle of the current, because you divide. So it's like the difference between them. So 0 minus minus 8 is equal to 13. Okay. What else? Power factor. Now we're supposed to calculate the power. There are many ways. And I already published on the folio some practice we can solve, and they have the final answer. Should review it. What is power factor? Want to understand the concept and how we calculate the power factor, which is really important. So what does it mean, power factor? Yes. And current. You are close. But when you say the difference in phase, it means power factor is an angle, right? Is not an angle. Yes. But it depends on the angle. This is the right part. Depends on the angle. Yes. Don't tell me cosine. And now just tell me, what does it mean? Not the power loss. Yes. Of the circuit. Not actually the efficiency of the circuit. Let me just, to make it closer, let me just, I will ask first another question. When you have DC circuit, you have only one type of power, right? The active power. And what? The one you consumed. When you have AC, you have 3 types of power. Have power, and sometimes they call it average power. So when you hear the word average, it means active, and it's P and the unit in watt. That's active power. And the other one, reactive power, and we call it Q, and the unit var. Volt, amp, reactive. And the last one, apparent power. And that's S. And the unit is volt amp. We have 3 types. What is the difference between each one? What is active power and what's reactive power? Yes. Yeah, power is real and the reactive power is imaginary. What about the physical meaning? What does it mean active power? What does it mean imaginary power? Yes.
What I know is the reactive power as possible.
Yes, that's true. The reactive power is not consumed, but used. Let me tell you the story about it. If you have resistance, like light bulb, not this kind of light bulb, the one has filament and things like that, that's produce heat, right? Why produce heat? Or the heater. If you have electric heater and you plug it, the wall, you find heat coming out. What does it mean? It means that the heater absorb the energy from the source, consume it in a form of heat. So it's consumed. That's why we call it real power, active power, because you consume it, it's gone. You got it, use it. But like that, if you have a resistant or resistive load and you have the supply, and then the power go there, it's gone, heat. But if you have inductor or capacitor, either one of them, if you connect one of them to the source, the energy going to the inductor, and the inductor return back the energy to the source. So it's like bouncing forward and back. So it's not consumed. Why? I'm talking about pure inductor or pure capacitor. Because they use an inductor, they use the energy from the supply to build the electric field. And the capacitor, magnetic field for the inductor, and the electric field by the capacitor. But they don't consume it. There's no heat coming out of it. Just they use it to make the field. That's all. So when you have the field, it's energy. So you didn't consume it. There's no heat coming out. Let me tell you a story about the power factor. Before they discover that the inductor and the capacitor, even if they don't take active power, but they have reactive power, but already in the power station, they use the fuel and they burn the fuel and consumed. And then I use it for the electric field, magnetic field, or have inductor or capacitor, especially in inductive load, most of the inductive. So I'm consuming energy, but the meter that you have even in your house, it's what? Kilowatt hour. So you'll find your bill comes for kilowatt hour. What is that? It's energy, but it depends on the power and the time. If you have a light bulb, 100 watt, and you turn it on like 8 hours a day, so you consume energy 800 watt hour. You divide it by 1,000, then you get 0.8 kilowatt hour. I'm talking about 1 day, 8 hours. Then you pay the bill according to this energy. But what about inductor, capacitor? They don't consume what? It's reactive power that go forward and backward from the source. But you don't have meter power. So what happened before that? It's okay in the house, you have few appliances and the inductive load is not really big. But when talking about industry, you have more transformers. You consume a lot of energy for the inductive load. Then the utility company, they found they are losing money. Even the people, they are paying money for whatever they consume, but only it was kilowatt hour. But they don't know where the rest of the energy is gone. Then they found that's like power. Then they start to make penalty for high consumption of the energy for the power. How do you do that? How do you calculate it? Using power factor. What's power factor? If you have the power consumed, or real power, or active power, P, it's horizontal. And the other one, imaginary, as you said. So that will be in this direction. That's Q. And that's the total power, or apparent power. That's what appeared to everybody that consumed. But this is only consumed, this is used, and S is the total used and consumed. So the ratio between P and S is the power factor. It's the ratio between consumed power and total power taken from the supply. That's how they make the penalty. And they said, it depends where it is. They said, like, you cannot be below 0.93. Sometimes 0.95. What does it mean? It means if you get energy from the utility company, I'm talking about industry, not houses, you should consume 93% out of it. If you consume less than that, we're going to have penalty. You pay penalty for this law. So they start to make something called power factor corrector, the industry. I remember that before they have the automatic power factor, I made good business from the power factor. I designed like power factor corrector for some industry, and it was like new thing. It's very simple concept, and like the company was paying penalty about 10 million every year penalty. That's plus the bill itself. So I offer I will do it by 1 million one time, and then they fix it all years, and they agree. So it's important about now they do automatic power factor corrector. When you go to any company, you find they have this big box power factor, and they adjust it 0.95, 0.94, and then it adjusts everything. So how do you do that? The inductor consume inductive reactive power. The capacitor does not consume inductive reactive power. It consumes capacitive reactive power, which means producing inductive reactive power. They are opposite. Let me explain. Inductive, Q. Capacitive, UC. So the reactive power of the capacitor opposite to QL. So if you have QL like that, you want to minimize it, just put capacitor on the parallel to the load. So let me make you visualize what's happening. If you have load like that, inductive, you're going to do that in the lab, by the way. And that's the source. And you're taking QL, you put capacitor here. Balance it. Then you can fix the power factor. What does it mean? That's if this QL and you put QC and you minimize it up to here, that's the total now. That's the what's happening total. So this part will be produced by the capacitor. That's how you minimize the Q, and then you improve the power factor. Your friend, he said that the angle between the voltage and the current. That's true. Because the angle between S and B is the same angle of the impedance, and the angle of the impedance is the angle between the voltage and the current. Confusing? How we calculate Z? Z is equal Z magnitude and angle theta. How you find the current? You say voltage over Z. Assume V on angle 0, just for simplicity. And will be Z magnitude in angle theta. So what you get? You get I magnitude, and 0 minus theta would be minus theta. So if the angle V 0 and angle I minus theta, so the angle between the voltage and the current, it's the angle of Z. What is the relationship between this and power? To find power, I will tell you about the formula called complex power. That's really excellent one. S equal V phasor I phasor conjugate. That's how you calculate the complex power. It will give you both power and reactive power. Let's take one example. V is equal 100 on angle 10. I is equal 5 amp angle 40. Let me make it lag to explain it more. So I'll make the current an angle negative 20. So that's the voltage, that's the current phasor. Now I want to find the power. I want to find P, Q, and S. So the best way to do it is using complex power. Complex power is S equal V phasor I phasor conjugate. B is equal 100 and angle 0. What about the current? 5 on angle negative 20, but the conjugate means changing the sign of the angle. That's the meaning of the conjugate. So what does mean conjugate? It means you don't change the values, change the sign of the imaginary part, or change the sign of the angle. Yes. I change what? That's a mistake. That's 10. Thank you. So the conjugate, if you do the conjugate, just all what's supposed to do, keep everything fine, the same value, just change the sign of the angle. And if it's expressed in complex form, keep the real part as it is, but the imaginary part, flip its sign. For example, if you have 5 plus J10, make it 5 minus J10. That's the only difference. That's the conjugate. So you have 5 on angle 20. I did the conjugate as the formula here. Now we multiply 500, 10, 20 will be 30. I just want to verify your friend when he said that it depends on the angle between the voltage and the current. So let me sketch the phasor for the voltage and the current. That's 0. The voltage in angle 10, that's 10. That's the voltage phasor. The current on angle, it's 5 on angle negative 20. So I make the current small and negative 20. -20. So what is the angle between the voltage and the current? 30, right? That's true. So 530 means that the total power, if I do the triangle, what triangle? We call this power triangle. Triangle, if you sketch it, you can sketch it here. The unit, volt amp. Why? It's S, apparent power. And the angle is 30. Observe, the angle is positive. It means the load is inductive. Another thing, the load is inductive. You have to pay attention to all details because in the exam, I'll just give you the angle is equal 30 degrees. The angle is equal -20 degrees. Is the load inductive or capacitive? So you got to keep in your mind, every single word has a meaning. So that's P, that's Q. Can you find the power P? Can you find the reactive power Q? Yes, you can. P here will be 500 times cosine 30. That would be equal to 500 times cosine 30. 33. And the unit is what? Q is equal 500 sine 30. 500 sine 30. It's equal to 50. Power factor, we got two options here. Power factor, you can divide the power by S. Can say is equal cosine 30. So power factor can be obtained using one of these two formulas. It's either cosine the angle between P and S, cosine the angle between P and S, it's the same as cosine the angle between the voltage and the current, or the ratio between P and S. That's the more general one. Power factor is equal cosine the angle. That's special case when everything is pure sinusoid. What does mean pure sinusoid? It means that pure sine. There is no disturbance. There is no noise in the waveform. There's no DC. Nothing. If there is something, then you got to go back to P of S. But in the course, we are using ideal sinusoidal, no noise superimposed on the signal. So you can use the power factor cosine the angle too. And when you do that, you'll find the value will be equal to 0.866. The answer is not complete. Power factor has two parts, value and the direction. The value is 0.866, but you got to mention, is it a power factor lagging or leading? Leading? Why? I know what you mean. The angle is positive. You talk about the current and the voltage. This point. The angle is positive in the power triangle. If the angle of power triangle is positive, it's lagging. Let me clear this point. What your friend is saying is right, but when he uses the current and the voltage. So if you have the voltage and you have the current leading, say that I leads the voltage. If you do the power triangle, you'll find that the power triangle like that. And the angle is negative. So there's difference between the angle of the current and the voltage. The angle between the current and the voltage is positive here. It means leading. But this angle of the power triangle. So if this is if the power triangle is negative, it's leading. So this power factor is leading. But if you have the voltage, the current lagging, we say that I lags voltage, and you will have lagging power factor. But the power triangle will be like that. So the power angle is positive. The power factor is lagging. Why? Because when you find the power, you multiply the voltage by the conjugate of the current. You flip the current. That's why. But I won't be confused. If you're looking for the current and the voltage, if the current lagging, it's lagging power factor. If the current leading, is leading power factor. That's right. But if you are looking at the power triangle, it's the opposite. Okay. For a minute, let's see what the problem here. Okay. I know I got a little bit deeper on that, but just it's a chance. So the power factor in this case, we got a 0.866 lagging, and it was obvious. Why? Because we're dealing with coil, and coil is inductive load. And inductive load always have lagging power factor. Capacitive load have leading power factor. Power consumed, we already got it. Power consumed here. That's the power consumed. 433 watts. Reactive power, 250 watt. So the problem is solved. So it's a good example on how to calculate the power. By the way, there are many ways to calculate the power. I wish that you can review, try to solve practice that put it in the Volio system. At the same time, next lecture, I'm going to continue to have when it's series, when it's parallel, and continue on that topic. Do you have any question? Because we still have 3 minutes. Do you have any question? Something not clear? Yeah. No. The direction. If the angle of the angle of the between the current and the voltage is equal positive 30. The angle, the phase angle is equal negative 30 between. So I mentioned the angle, the sine, the value of the sine, and between current and voltage or power triangle. So you got to be aware which one I'm asking about, because both they are opposite. Yeah. Yes.
So you call
Another question. Okay. Well, next time when we do example, consider certain questions. Have questions. You understood everything, right? The attendance, everybody.